Hi everyone and welcome to our group project, second project, data analysis based on internal statistics. And today we'll be discussing our findings on study habits and their impact on student success. We are from group 10. Chao Chian, Wing Weiji, Maaz Mursi, and me, Ahmed Mohammed. This is our group. And regarding the table of content, we included introduction, dataset, data analysis, conclusion, and appendix. In the introduction, there is purpose of study, interest, our expectation, and in the data analysis, there is hypothesis, one sample, test, correlation test, regression test, and chi-square test. First, in the beginning, understanding academic performance is very important for developing effective and educational strategies. Our study focuses on analyzing attributes like hour of study, practice hours, teamwork hours, midterm scores, final scores, and overall scores. The purpose of this study is to examine how different study habits and collaborative activities can contribute to academic performance. So, by analyzing this data, we aim to identify key factors that correlate with higher scores and better grades. For the interest, we are particularly interested in understanding the dynamics of academic success, especially how the balance between individual study and teamwork impacts performance. Our investigation seeks to uncover the best practices for effective studying and collaboration. For our expectation, we have decided that students who dedicate more time to studying and engaging in teamwork will achieve higher scores. We expect significant correlations between study habits and exam results, emphasizing the importance of effective study strategies. Okay, for the dataset, our dataset includes various attributes related to student performance, like hours of study. This is the total hour spent studying. Practice, hours spent on practice activities. Teamwork, hours in collaborative sessions, midterm, final exams, and overall scores and the grade received. Okay. For the data pre-processing, we ensure data accuracy, addressing any missing values and checking for outliers to maintain the integrity of our analysis. For the choice of variables, these variables or their parameters were selected because they directly influence the learning process and outcome measures such as exam scores and final grades. For the possible outcomes, we want to identify if there is any correlation between study hours, practice, and teamwork with exam scores and overall scores. This analysis will help us understand the relative importance of each factor in achieving academic success and provide actionable recommendations for students to improve their performance. Before we started our analysis, we calculated the mean, standard deviation, and variance, so we can implement it in any test that we will make it in the project.
So hello, my name is Zhao Tian and I come from group 10. And now I will explain our data analysis part of the project. So the first part is about the hypothesis, one sample test, which describes the relationship between the study habits and overall academic resources. We can say there are two hypotheses here. One is the null hypothesis, means H0, and another one is alternative hypothesis, H1, means there is a significant correlation between the study habits and overall academic resources. So we can say the null hypothesis H0, we can assume mu is equal to the 50. And alternative hypothesis H1 is mu not equal to the 50. Now we can, according to the equation, to calculate the z value. So the z is equal to the x minus mu divided by the sigma divided by the square root of n. So here the x is 51.48 as we mentioned in the part of that set, and the mu is to 50, and the sigma is equal to the 25.29, and the n is the number of the sample in the dataset, which is 25. So we can say the value of z is equal to the 0.2925. And now we can determine the theoretical value for this given significance level. We can assume the alpha is equal to the 0.05. And for the two-tiered test we have with the situation of alpha is equal to the 0.05. So we can send the theoretical values of z is equal to negative 1.96 and positive 1.96. And then we can use the two-tiered test with the situation of alpha is equal to the 0.05. And we can send the p-value is equal to the 1 minus 0.4744 minus 0.5256 is square of 2, which is 1.0512. And according to the situation we mentioned above, we can draw the graph, which that we can send the 0.4744 is between the square of the negative 1.96 and positive 1.96. So we can get the conclusion that 1.0512 is more than 0.05, so we can fail to reject. And now I will explain the correlation test of the project. So this correlation test project describes the relationship between the final exam results and also the study hours in the dataset. So here is the scatter plot, which is y is the final exam scores and x is the study hours in the dataset. And here is the edit form, which describes the x, y, xy, x square, and y square for the dataset, and also the R code for the dataset. And now we can have the hypothesis here, which is hypothesis 0, there is no correlation, and H1 is there is a correlation. So now we can start to calculate the value of R. So according to the equation of R is equal to the 0.2349. And then we can start to calculate the value of the t-test. So according to the equation of t is equal to R divided by the square root of 1 minus R square and divided by the n minus 2. Here n is the number of the sample, which is 25, and r is mentioned in here. The r is equal to the 0.2349, and then we can get the t value is 1.16. So now we can calculate the curative value with the situation that alpha is equal to the 0.05 and df is n minus 2. N is 25, so df is 23. So according to the situation we mentioned above, so we can draw the graph like this. So we can easily see that t value is 1.16 is between the space of negative 2.0687 and positive 2.0687. So we can get a conclusion that we can reject the H0.
Okay, hi doctor. Then I will present the last two tests. So for the 3.3 regression test, this regression test is used to analyze the linear relationship between study time and the students' scores. The results show that study time has a significant positive impact on scores. For every additional hour spent studying, the average score increases by approximately 9.7785 points. The regression analysis indicates a strong linear relationship with a coefficient of determination of 0.9529, meaning that most of the variation in scores can be explained by study time. So first, we establish the regression model using the formula where y represents scores and the x represents study time. Next, we calculate the coefficients. The intercept B0 equal to 2.48367 indicates that when no time is spent studying, the predict score is 2.48 points. The slope B1 equal to 9.7758 shows that each additional hour of study time increases the average score by 9.7758 points. Then perform a t-test to verify the linear relationship with critical t-values of minus 1.96 and 1.96. The calculated t-value of 21.5829 is greater than 1.96. So we reject the null hypothesis, confirming the linear relationship between study time and the scores. Finally, calculate the coefficient of determination is equal to 0.9529, indicates a strong linear relationship between study time and the scores. Then we go to the 3.4 chi-square test. So for the chi-square test is used to analyze the distribution of students' scores across different intervals. The results show that the distribution of scores across different intervals is not uniform, with at least one score interval having a significantly different proportion from the others. So therefore we reject the null hypothesis, confirming that there is a significant difference in score distribution. So first, we just divide the score into different intervals such as 0 to 20, 21 to 40, 41 to 60, 61 to 80, and 81 to 100. Then calculate the observed frequency and the expected frequency for each interval, with the expected frequency is equal to total sample size minus number of intervals, so it's equal to 5. Then next, use the formula to calculate the calculate the chi-square statistics, which is 4.0. Then look at the critical value from the chi-square distribution table, giving 0.05, and the degree of freedom is equal to 4, right? So then we can see the result is 9.488. Finally, since the calculated chi-square statistics is 4.0, which is less than the critical value 9.488, we cannot reject the null hypothesis. Then indicating that the distribution of scores across different intervals is not uniform, with some intervals having significantly different proportions. So then is the conclusion for our project. This study's conclusion emphasizes how important productive study, hobbies, and teamwork are to attending academic success. Higher exam scores and better marks are highly connected with longer study sessions and active teamwork. Putting into practice well-structured study strategies that strike a balance between solo and group learning can greatly improve student performance. In order to access pupils in their academic endeavors, educators must advocate for these approaches. Okay, then I think that's all about our project. Thank you.
Hello and good day to you. This is Muaz Mursi, and in this part I'm going to make analysis of student grade using R language. I will walk you through the dataset and the R script that we have been used in this project in order to make our analysis. So first of all, I'm going to give you an overview for the dataset. Our dataset basically contains some important information about students, such as the number of student of ours scores, practice score, teamwork score, midterm exam score, final exam score, and the total score with grade assigned for each single student. So for example, we have 26 students and their criteria that we do analysis based on them. So now I'm going to give you an details with the explanation for the R script language. Firstly, we need to load the necessary R package with the CSV information by using these libraries. And then viewing data. It's very important to examine the structure and display the first few rows of the data in order to understand the content. The group teamwork. We need to group the teamwork. We had to group the teamwork scores into high and low based on median criteria. Based on the median. So we declare a variable called teamwork by using data. Then we gonna check the distribution of the group work. The program will print teamwork group distribution. So the for the main, then the program after get the information from the group teamwork, the program will calculate and compare the score for two teamwork and get the main by print main score by teamwork group. For single sample tests, in order to perform it, we compare the overall student score with the hypothetical mean score, which is 75. And we declare variable called score by using data to save the information. For calculate the correlation coefficient, we declare the two variables called hours and final exam and compare between them to get the correlation coefficient for each student. Then for regression line, we fit the linear regression model by compare the scores, hours, practice, teamwork, midterm score, final exam score, and declare it with the variable called data. Then the program will display a summary of regression model. Okay. Then we clear a variable called best in order to test the chi-square test. So the program will compare or will test the score. If the score equal or greater than 60, it will make the calculation. Also, we declare a variable called teamwork, group, and best. Okay, I think that's all for this part. Thank you.
So for the reflection of this course, I learned how to use statistical techniques as tools for data analysis. Initially, I was exposed to various forms of data derived from different sources in daily and industry activities represented by different types of variables. I learned how to represent data visually, which helped me understand data distributions and trends more intuitively. Additionally, I explored methods for parameter estimation from different distributions, enabling me to describe data characteristics more accurately. In diving deeper into data analysis, I mastered hypothesis testing methods to verify whether the relationships and the differences between data are significant. I also learned how to use various statistical models to fit groups of data, thereby better understanding the predicting data trends. So I think that's all. Thank you.